Welcome back to some math. That's the cool song you get today. Welcome. Hey, another video. How fun is that? Today we're going to be talking about the sums and the differences of mixed numbers. This is like day three. Day three. So today is really about reviewing a lot of things we've been talking about and then practicing those procedures to make sense of things and to make sure we just really kind of understand what we're doing. So again, remember, if we're talking about sums, right, we're talking about the answer to an addition problem. If we're talking about differences, we're talking about the answer to a subtraction problem. And then, yeah, we're referring to mixed numbers. So remembering the concept of a mixed number is when you have a whole number and a fraction. Fraction. Whoa, what is that? So I don't know why I wrote that. So for example, like 3 and 5/9, that is a mixed number, right? Because it has a whole number and then a fraction. So we're really looking at today is like, what happens when you take something like 3 and 5/9 and you add 2 and 5/7, right? Like that's just an example. So that would be the sums of mixed numbers because you would have an answer when you're done. Or one might ask the question, what happens when you subtract these two numbers? So you have 5 and 3/9 and you take away 2 and 5/7, right? Again, that would be the difference. So we're going to look at the two methods that we practice, and then we're going to play around with some questions. Wow, that apparently says difference right there. What does that say? What do you say? I am so confused. I'm always like, oh, I'm gonna make this video shorter, and then I draw pictures. Okay, so let's talk about one of the methods we talked about, and that's the steps method, right? That's just the idea of like walking through and asking yourself some questions, right? Question one, regardless, every single time, are my fractions compatible? Again, meaning are my denominators the same? So if I have 3/5 and I have 4/5, they are compatible. If I was to have 3/5 and 9/20, they are not as compatible. We can still work with them. We just can't work with them in this form, right? So then we kind of follow this flow chart. So when they are compatible, again, we can just add or subtract the numerator, whatever it's asking us to do. And then we slide that denominator over. Because remember, the denominator is telling us how big the pieces are. We're not doing any math with it. It's just talking about how big those pieces are, right? In this scenario, as always, I love the pizza. I don't know why I always pick the pizza, but it's easy to think about it that way. You know, a pizza has been cut into 5 slices, and we have 3 slices left. That's really what that means, right? If we're not compatible, which is fine, that just means we're not ready to work together yet. We can make sure that we find equivalent fractions using the least common multiple. We convert those so that they are compatible, so their denominators are the same, and then we follow those same steps. So that's like the step method. And we'll practice both these problems today. Don't worry. This is just a quick review. Our second is this newest one where we can actually use the concept of converting to improper fractions, asking that questions if they're compatible, and then do the math, right? Do the steps that we see in here, and then convert it back to a mixed number to get an answer. So with that being said, let's just dive in today. And I think a lot of times it's often thinking like, what does the problem present to me to where I can make sense of this? So right away, first problem, 13 minus 10 and 1/3. Well, obviously, I don't even have two mixed numbers here. I have a whole number minus a mixed number. So when I think about that, I don't think this converting process is going to work because I'm not sure how I want to make this an improper fraction accordingly. So I'm going to go with this system here, right? So the first thing I'm going to ask myself is, are these fractions compatible? Well, this whole doesn't actually have a fraction, but I can make a fraction out of it. This is part of that decomposing, right? Because I can look at the fact that this 13 is literally the same thing as 12 plus 3/3, right? Because that is what that's saying, because 3/3 is actually equal to 1. So 12 plus 1, that gets me 13. So I can actually rewrite this as a mixed number. 13 can be rewritten as a mixed number of 12 and 3/3. And then once I've done that, let's just go and we're going to say minus 1/3. Okay. I'm gonna erase this over here so you don't get confused. Like, what is that going on? Oh, that's not true, right? That was just how I converted it. Okay, and so now let's go back. Like, okay, are they compatible? Yes, they are. So I'm gonna go ahead and I'm gonna keep my denominator, and I'm just gonna do some math. 3 minus 1, that's gonna get me 2. Yo, oh, okay. Um, and then I'm gonna go ahead and do my whole numbers. So I'm gonna go 12 minus my 10, and that's gonna get me 2. And then there we have it. When I take 13 minus 10 and 1/3, I actually get 2 and 2/3 left. And that's one way of doing that, right? We just followed the step process. That works. We followed those steps. So let's tackle another one. Let's see another example of what we can do. So let's look at another problem here. Let's say we have 4 and or no, just kidding. Did I say 4? That was a joke. Ha ha ha. I'm gonna say 2 and or 8 and 2/3, and I'm gonna subtract 2 and 1/2, right? So I already recognize looking at this that I kind of seem to have a problem. Like I know they're not compatible. I also know that like in some case I might not be able to do like I don't know, I might have to regroup in this situation. I'm not sure. So what I'm going to do is I'm going to go to the converting method. I like this one because it does allow me to then think about what I'm going to do. So first I'm going to turn these into improper fractions. So that means I have 3 parts times 8 wholes, right? Because there's 8 wholes and each one has 3 parts. So that's 24 pieces plus these 2 more pieces. So that's 26/3. Again, I really recommend if this converting process doesn't make sense to you, that's something that you want to seek out help with. Like it's going to be helpful, right? And then we got 2 and 1/4. So that is 2 wholes, 4 pieces each. So that's 8 pieces plus this 1 piece. That gives me 9/4, right? And those are equivalent. 26/3 is the same thing as 8 and 2/3. 2 and 1/4 is the same thing as 9/4. They're equivalent. That's why we say convert. We're just changing the way that it looks. Now, I can go back then, think about, let's jump back here. Okay, we did that. Are they compatible, right? And if not, we'll just go do the math. Well, let's see. Well, they're definitely not compatible. So I'm going to go ahead and do my LCM work. Thinking I have 3, 6, 9, 12, 15, 18, 21. That was for 3. And then I have 4, 8, 12. I guess I should be putting commas in here. Oh, 12. Okay, 12 works. So I actually have to change both of these. Woo! Okay. This is where like math, all the great math I get to do. I think that was something I mentioned is like, I like this strategy because it does challenge my brain to do a little more math. Okay, so that means here I'm multiplying by 4. So I need to multiply 26 by 4. Oh boy, okay. Let's see, 26 times 4 is 4 times 6 and 4 times 20. So that's 24. That's 80. So it's 104. So 104/12. That's what this one is, 104/12. I'll change colors for this other one. So then we have 9/4, and I'm making it out of 12. So that's times 3. So that's 27/12. Whew, that made it a little bit easier. Okay. And now we're just gonna follow through, right? Like now we know we have, and I'm sorry, this is that one thing about I don't want to, I'm going to erase this so we have some more work time. Hopefully you saw how we got there. And if not, rewind the video and pause it and take a look at that. And then we're just going to do this math here, right? My denominator stays the same. And then I have 104 minus 27. Let's see, that does not work. So I need to do some regrouping. 77. So 77/12, but I'm not done. So this is that last piece here where I need to convert it back to a mixed number. So I am going to go ahead and take this. And remember, this is a division problem. This is literally saying I got 77 and I'm dividing by 12. So let's see here. What do I know? I know that 12 times 10 is 120, but that's too big. But I could take a half. 12 times 5, that's 60. I'm going to do that. I'm going to go group of 5. That's 6. You have 17 left. Oh, I could do one more group. That's 12. That would give me 5. Okay, so here's my remainder. So I end up with, when I take 77 halves, that actually equals 5 wholes and 5 out of 12s, right? And that's why, sorry, that got really close. That's why we do the work that we do with writing remainders as mixed numbers, because it really comes in handy at this point, because when we're converting. So that works. So there we have it. A couple more problems, like one way or the other. So let's just try one more. I want you to, this is one of those scenarios where I think it would be really helpful to, once I write this up, to pause the video and do this work in your journal and like make sense of like, what strategy would you use? Are you going to use the conversion method? Are you going to use the steps method? What is making more sense to you? So I'm hoping you're pausing me now, and thank you for doing that. And let's come back and look at what you did. So I'm guessing you already went about this. I'm going to go with the steps method, right? Keep in mind that if you do conversion, we're going to have the same answer at the end of this. So don't worry, but let's go ahead and think about this idea of the steps message, right? And the first thing is, are my fractions compatible? Which they are not, right? They are not the same denominator. Now I can make them compatible again by using that LCM. I'm going to find the multiples of those denominators, but you know what? I actually think it's just 15, isn't it? Because 5, 10, 15. Yeah, cool. So 15 is my LCM, which means I don't have to convert this to anything. This stays as 11 and 2/15. But 3/5 here, I need to make that out of 15, which means I'm multiplying by 3. So that would get me 9/15. And this is a 4. Okay, cool. Now that I have compatible fractions, let me change that. Again, right, they're compatible, so I'm going to have 15, and then I'm going to add up here. That gets me 11. And then I'm going to add my whole numbers, right? These are all the things we've been practicing. So 4 plus 11, that's going to get me 15. And so it looks like I get 15 and 11/15. So with that being said, this is the work we're doing today, right? This is a bit of review, right? It doesn't mean you can't ask questions. So make sure you're asking questions, but think about like, what process are you using? Are you using this conversion method? Are you following the steps and thinking about making sense of making compatible fractions? Whatever it may be, continue to do great work, ask questions, and we'll see you at the next video. Appreciate you. You are wonderful, and we'll see you later. I think I already said that. Bye.